Okay, so we'll go under the menu item under refactor, and under all of these possibilities, there's one that just happens to say extract interface. And all that it does is it presents you with all of the methods and says, which ones of these do you want to include in the interface? And so in this case, I'm going to say I want them all except toString, because toString is sort of a standard. I don't care whether you write it or not, really. Okay. So those are the ones we can write. Oh, what the heck, let's make us write the toString. Okay, sort of a special case. And I'm just going to get rid of some of these things because they're not necessarily all that important. Yeah, sure, we'll give that a try. What are we going to call this thing? We'll call this thing list interface. Okay. And the method comments we don't need. And let's just see what Eclipse does for us. Give it just a second here. Here's the list interface that's been created for us. And it's just got the interface with the names of all of the methods that we have to write. Okay? So if you want to pretend to be a list, you're going to have an add method, a remove method, a get position, a size, those sorts of things. And if we look at what it did to ObjectList at the top, it was kind enough to go into ObjectList and say, oh, this now implements list interface. Okay? So it promises to do all of the things that the interface does. So it's basically working backwards from a sample one to get an interface, instead of the other way around, working from a standard to actually make a standard. Okay? Now that we've got that, let's make a new class that does a ChainedList instead. So we'll go and we'll make a brand new class, and I'm going to call it ChainedList. And make the class, and then I'm going to say implements list interface. And now it will complain and say, hey, you've broken your promise. You need to add all of these methods. So we'll go in and we'll say, those are the methods that I have to write. And now we know what we have to make this thing do to behave like the other list. Okay? So now we've got this thing sort of all set to go. We're going to make a new chained list. When you make a new chained list, what variables is the chained list need to keep track of from the diagram?
The starting area of the list?
It needs to keep track of that note that says here's where you go to find the first thing on the chain. And just for fun, we'll keep the count of the number of items that we've got, because it's easier to keep track of it than to have to go down to a list and count them all of the time. Okay. Well, count is easy. And we've got this other variable that's going to keep track of the start of the chain. What kind of variable should that start variable be? Let's go back and look at the equivalent. Okay, this was the thing that we had in the gift game that held the chain together. So we need one of those things to form the chain. The only thing that's different is that instead of saying string, it's going to say object. Okay. Now, here's the next question about this thing. This stuff that we're using to build the chain, does the outside world ever have to see it? Just like in the sense of here, we never told somebody when you said add something to a list, this list, we never let them see the array. In this version, we're not going to let anybody see the fact that we're using these things chained together. And so this thing that holds the two objects together, we're going to hide it inside the list class. Okay? And so what I'm going to do is I'm going to take all of this old gift location class and I'm going to stuff it inside ChainedList down at the bottom of the class inside the last curly brace, and I'm going to mark it as private to say only I get to see it. Okay? The analogy here is you go to a warehouse with your toaster and say, I want to store my toaster in the warehouse. The guy in the warehouse says, well, we just don't store things like this. We need to put them in a box. And so as soon as you've left, he takes the toaster, he stuffs it into a 2 cubic foot box, he writes your name on the front, and he puts the box away someplace. When you ask for it back, he brings the box to the front, takes the toaster out of the box, and hands you the toaster. And so the box is always something that's internal to the warehouse that's used to organize the warehouse. It's not something that you get to use in the outside world. So the same thing here, we're going to hide this thing that chains things together where nobody can see it. And now I'm just going to do a little bit of work. I'm going to change the name of it, and instead of calling it gift location, I'm going to use the computer science term, and I'm going to call it node here. And so there's the refactor saying, okay, that's now a node. And the only other change that I'm going to make to this thing is to say that instead of taking string, we're going to be able to store anything on this chain. And so it's no longer going to be strings, but it's going to be objects. Okay, so it's still the same class it was. I just basically renamed it and made it a little more general. And the toString is sort of broken. What should the toString return? If I ask you about this thing, say print out the interesting information about this thing, what's the interesting information?
The toString of gift.
Yeah, the interesting information is whatever B has to say about itself. And so the trick here is to call this gift.toString and say you're not really interested in me, but you're interested in the thing that I'm holding on to. And gift is probably a bad name. I'm going to change this thing and call it thing to store. I can get my caps lock off. Close enough. Okay, so now that we've got that done, that start variable up here is just going to refer to the first node on the chain. And so now we know what this variable is. That thing's a node, where to find the start of the chain. See what it's upset about there. Nothing serious at this point yet. Okay. So let's just write a main program here just to play with this thing for a second. I'm going to copy this worker into here so that we've got something to actually, yeah, sure. I'm going to copy the worker in there so that we've got some test data to work with. And I'm also going to make a new driver program just so that we can see it work, doing its thing outside of a unit test. And we'll just start writing this thing from the top down. So what I'm going to do is I'm going to make a new worker. just like we do for array list. He had 2 arguments, I guess. And we'll make a new list, and this is now going to be a chained list. And then we would turn around and do a list dot add Fred to have the list remember him somehow. Okay? So there's a simple version of the driver program. So there's my call to the chained list constructor. We need to write a chained list constructor. What should the start variable be initialized to? Here's a list. Constructor comes along and says, let's create those 2 variables. What value should they start out with? Null for here and 0 for that one. Nothing on the chain, and the count of the items is 0. Then we call lists add. We've now got list is coming along and saying there's A. A has some address. I'm just replicating the same diagram down below as we go, right? So there's A at address 5,000. The list is past that number 5,000 and says, I want you to add this item onto the chain. Do the simple thing. How do you get that item onto the chain? What's missing from the diagram to start with? Need a new node object in here. Okay? So the first thing that we'll do in our add is we'll create a new node object. And let's just go see what the node constructor takes, the thing that we're trying to store. So the thing that we're trying to store is the what variable. Okay, so on our diagram, that has the effect of making the node. The node we're calling a node. It refers to that thing. We took the address 5,000 and dropped it into there. So the node is holding on to that item. How do you get this thing onto the chain?
Set start to that node.
So we're trying to draw that line there that connects the start variable to that box. Okay? There's the start variable. There's the 4,000 that we need. The thing that's holding on to the 4,000 is the a node variable. So we're going to take the value that's in the a node variable and we're going to move it into the start variable. So we'll take the value that's in a node, drop it into the start variable. And that says take the value 4,000, dump it into there, and so that says there's the first thing that's on the chain. happens to the count variable? Now got one item on the list, so the count variable needs to go up to say we've got one more, so count goes up to 1. If we just leave this code as is, that gets the thing chained in. That temporary node variable disappears, and we've now got the first item on the chain.
You add a new one, just overwrite start.
Going too fast. Yeah, it's broken, but that's okay. We just did put on the rose-colored glasses, and oh, look, I got the first one on. Life is really, really good. Okay. So this thing comes back to the main program. Oh, look, we've got something magically, one thing stored on the chain. Okay. Now the naysayer is going to come in and go, oh, suppose that you add another item. Like that. Okay, well, let's go follow the code along. This is just, we do new worker again, or new whatever it is. This has made another new item, this B item. That thing has some address. That address gets passed into the add routine as 6,000. We're going to drop that 6,000 into the what variable. And we come into our chained list, and we're saying we need to get that thing onto the chain. If we follow the code as it stands, the code says make a new node, copy the value of the 6,000 into that node so that it refers to that. And then now the code says take that 6,000 and put it in the start variable. And the problem with that is that it would ignore this one and it would chain that one up to the start. Okay? So the code that we wrote was okay, but it only works the first time through. And when we go to do it the second time, we've got a problem. In other words, the first time is a special case. What do we do to code that's a special case? Put it in an if statement. Okay? So if this code here is a special case, let's put an if statement around it to say if it's the first time, then that's what we would do. And then we'd be done. Run format on that. So now we've kicked out the special case for the first time, and now we're worried about, oh, I guess this is past the first time, this is the second time through. Okay, so here we are. It's not the first time anymore, it's the second time. What are you going to do now?
While statement to go through all the nodes to get to the end.
Yeah, the trick here sometimes when you do these examples, if you get past the first case, you're going to now generalize it, right? And the general case is actually you could have a whole long chain of things here, not just one thing, but there could be many, many, many things. And the goal is to somehow get to the end of however many things that you've got so you can put it onto the end. Okay? And so let's just imagine that for a second, that we actually had a diagram that looked like this, and we were trying to chain something onto the end. What would you do to get to the end of the chain?
You use your count variable? Can't right now because they don't reference each other. You have to do
I want to be standing over here. But right now, where am I? This thing says I'm right there. How am I going to get down to there? Can't change this variable, the start variable. So I need a temporary variable that's going to start here that I'm going to bump down until I get to the point where I want to be. Okay? So we're going to copy the value of that 4,000 into a temporary variable, get it standing over top of the first one, and then keep moving it along to stand over top of them until we get to the last item. So that's just like the kid saying, I'm going to write where I want to go on my hand, leave the piece of paper in the living room, and then I'm just going to follow whatever's on my hand, replacing the value on my hand until I get to the endmost item on the list. So we need a variable to keep track of where we are now as we're stepping through. Okay? Quite often in coding, you'll see that referred to as a current variable. Where am I currently at? And so that's just a word that programmers use to say this thing is sort of temporary. Okay? What kind of variable is current going to be? It's going to be a node because it's referring to nodes. What value should it have to begin with? Same thing that the start variable has. So we're going to copy, if the start variable has 4,000, we copy the 4,000 into there. Okay? So now we've got this thing standing over top of the first one. When do you know that you've hit the end? When this one, if this was current dot get next, doesn't refer to anything. So if you reach a point where current dot get next doesn't refer to anything else, then you know you've reached the end. So that's what we did yesterday. Current dot get next is not equal to null. Now, the other way of writing that you'll also see is you could count them. You could write a counted loop because you know how many times you have to step forward. But it's just as easy to say until I've reached the end. Okay, so most often you'll see it written that way. Okay, so there's current dot get next isn't equal to null, which refers to that one. How are you going to make current advance? What was the magic that we had yesterday? There was a phrase I said that was consistent for stepping one forward on a chain. You can figure it out. If this thing points to a 7,000, then the goal here is to take current dot next and copy it back into current. So you put a 7,000 over top of there, which makes current advance. So the phrase to do that is always current equals current dot get next. Okay? So in this sort of chained code, you see this idea all the time. And anytime you see a loop that says, well, this thing isn't null, current equals current dot next, all that you have to imagine is this means I'm getting to the end. Okay? That's what that whole phrase means. I want to get to the end of this chain by stepping one at a time. Okay? So eventually current has reached the point where it's standing over top of this one. Now what do you want to do? Have to change the value of this current dot next to refer to that node. say. So that becomes current dot set next to the value of a node. So even if there's only one thing on the list, as soon as there's one thing on the list, current dot next is empty, and so you immediately chain current dot set next to that new one that's added. Okay, so this is what happens the first time you run the code. The second time you run the code, there's nothing for the loop to do, so it just chains it in directly. And it isn't until you add the third item that you have something to skip over, and then the while loop actually does some work. Okay. One other thing, now that we've put the thing on the chain, how many items do you have on the list? One more than you had before, so the count variable needs to be incremented there also. So the general rule for classes is anytime you change one of the variables in the class, you should go look at the other one at the top of the file and see whether or not it has to change also. So we changed the chain. We also need to change the count variable to make it agree with the number of items that are on the chain. Okay, well, I guess then we could add in a bunch more people. We'll add some other worker.
Do we even really need the count in there, though?
You don't need the count, but then if somebody asks you how many are items on the list, you always have to run down the chain and count them.
Oh, yeah.
So like, how many birthday presents do you have? If they ask that frequently, you get to run down the list. So it's just easier in this case to keep track of it. And I also did it that way because it's consistent with the other one. Okay, so there's adding 3 items onto the list, and apparently it adds them on and does something, but we don't know what. So let's go back into ChainedList and see whether or not we can retrieve them. What should size return? Should return, which in this case is count. So we know what that one is. That's really easy. Okay. How about this one? Suppose somebody says, get me item 5 off the list. Or item 3 or whatever it happens to be. So in general, you're going to have to, if they say 5, you're going to have to start at the beginning and run down until through all of the items until you get to the one that I want. Does that seem familiar to a problem we just did? It's sort of the same as adding, right? Instead of adding an add, we had to get right to the end. In the case of go get position, we're not necessarily going all the way to the end, but we're still stomping down the list until we get to the one that we want. Okay, so in this case, we're still going to, just like the way we added, we're going to need a current variable that keeps track of where we are to start with. And then current is going to have to advance down the list some number of times. It's going to have to do it more than once. So that's some sort of for loop. in order to advance a specific count number of times down the list. For loops are int I equals 0, I is less than some number of things, I plus plus. If somebody says, get me the 0 position, how many times do you have to advance?
Oh, we don't have to advance any times.
Don't have to advance at all, so that loop shouldn't execute if I send in a 0. So chances are pretty good that that thing is I is less than position for a value. So if we send in a 0, it doesn't do the loop at all. If we send in a 1, it advances one time and then stops. That's a pretty good guess. What's the thing that you want to send back? How about current? Oh, look, it works. Is that correct? Take a look at your diagram. Made the current variable. The current variable is referring to this thing, to that thing, to that thing. It's referring to nodes. What's the thing that you actually are trying to store on the list? Those things, which aren't nodes, those are the things that the node is holding on to. Okay? So in this case, you don't want to give them back this thing. In the warehouse analogy, this is like the toaster got put in the box, and when somebody asks for their toaster back, you give them the toaster plus the box. Okay? That's what you use to store things. They don't need to see that. The only thing that you want to give them back is the toaster, which is hiding inside of the box. And so we're going to go dig the toaster out of the box by saying return current dot thing to store we can look at, so we'll just turn that directly. So when we made our node to begin with, right off the top, we plugged that thing that we were asked to store into the node, and so when we retrieve it for people, we're going to turn around and we're going to dig it back out of the node and give it back to them. Okay? And notice that Java doesn't complain about that, because when you say object, any old object will do. And we're going to have to find a way to strengthen that later, but for now we'll just recognize that it's a bit of a problem, and we have to be really careful about saying exactly what we mean on that statement.
So would you be able to return a string?
It'll return anything for now, but we'll get to how to fix it to make it more exclusive.
With the object, you'd be able to return a string? So you're talking about strings being
Strings are object. You can still put strings in. You can still store strings on the list. Works just fine. And one last thing, I guess we should then check and see whether or not this actually works. So let's just write a loop to go through all of them, just like we'd go through a regular list. I equals 0, I is less than a list dot size, I plus plus. We'd call, I'm going to do it this way to start with, worker who is talk to the list, a list dot get position I, and then we'd print it out. And who has a toString to print it out. Why doesn't it like that line? Yeah, workers get dumped onto the list, but once workers are put onto the list, when we send them back, they lose their identity the kind of thing that they are, because we're only promising to return generic objects back. We're not promising to return workers back. We know in this case it's a worker, so what we'll do here is we'll cast this thing to a worker to say, no, damn it, I know I put workers on, so I'm going to get workers off the list. And at that point, when we run the thing, oops, there's all of our people stored on the list. Okay. So notice that as far as we're concerned in the driver, this thing behaves just like the other list behaves. You just take things and plop them onto the list. The only thing that's different between this chained list versus the object list that has this array underneath is how they store things where we can't see them. They have different performance characteristics, but to the outside world, they look identical in terms of how we talk to them. For next class, we need to finish off chained list, so we need to figure out how to write the remove method, which we've ignored so far. And the other thing that we're going to do is since these two lists are identical in how we talk to them, I'm going to actually go steal all of the unit tests that we did when we tested ObjectList. I'm going to change it to say ChainedList instead, and I'm going to run the same set of unit tests against the ChainedList and see whether or not it works correctly. So there's the other joy of things. We've got a set of unit tests that say, well, if those are your behaviors, I can test all of these methods in the same way, and it should still behave the same. And that's it for today.